Okay, good morning class. So today we're looking at geometry. We're looking at page 23. Correct? Alright. So here we are told that PQRS is a rhombus. What comes to mind? How many properties are there of a rhombus? 5. Okay, what are the properties? All sides are equal, yes? Two pairs of opposite angles are equal, yes? Two pairs of opposite sides are parallel, yes? Diagonals bisect each other, yes? The diagonals bisect these vertex angles, not so. So it's 6 actually. Diagonals are perpendicular. There are 6 properties of a rhombus. All of those are evident. The question says prove that triangle PQT is congruent to triangle PST. Okay, so what we have here? We have a common side, not so? We have those to be 90. And we have diagonals bisecting each other. Not so. Or, I could have gone common, angles bisecting each other, and these things are equal. Side, side, side. Not so? Or I could have gone side, angle, because that angle is equal to that angle, side. Or, I could have gone RHS. Or I could have gone angle, angle, side. I could have actually used all 4 cases of congruency here. Any one of it would have gotten me the full mark anyway. You guys understand? Alright, so let's go. Oh, by using all by using all 4 cases of congruency. Okay, so let's go with the first one. Let's go with our favorite, no? Angle, angle, side. Right. So where do we start? In triangle PQRT and triangle PST. What can I say? So I'm going to use 2 angles on the side. So angle P1 is equal to P2. Why? With diagonal, it would be a diagonal bisect the vertex angle. So that angle is equal to that angle. Do we know that T3 is equal to T4, which is equal to 90 degrees. Why? Because the diagonals are perpendicular in rhombus. I forgot to say here in the rhombus. No? That is 90, 90. Okay. So I have 2 angles and a side. So now I can use that side, that it doesn't matter. So now I'm going to say that QT is equal to TS. Why is QT equal to TS? Because diagonals bisect each other in a rhombus. Okay, that's enough to conclude. Therefore, triangle PQT is congruent to triangle PST. Why? Angle, angle, side. Okay. Let's go with the next one. RHS. I think that one's not used so often. Okay. This is the RHS one. So we're saying that T3 is equal to T4, which is equal to 90. Why? Why is this 90? Diagonals are perpendicular in rhombus. we know that PQ is equal to PS. Why? Why is that equal? All sides are equal in their rhombus. Okay. One more. PT is a common side. So we had R, right hand, hypotenuse, and any side. Okay. So therefore triangle PQT similar is congruent to triangle PS. Why? RH. Okay. Let's look at the next one. Side angle side. So I'm going to use side angle side. Or I could have used side angle, doesn't matter. But since I got that marking here already, PQ, no, that's your hypotenuse. Side angle side. Remember, when you use side angle side, this must be the included angle. Okay. So we say that T3 is equal to T4. It's equal to 90y. Diagonals perpendicular in the rhombus. Then we say that PT is a common side. One more, which is QT is equal to TS. Why? The diagonals bisect in the rhombus. So bisect each other in the rhombus. So there we have that as well. So it should be side angle side. So therefore triangle PQT is congruent to triangle PST side angle side. Okay. And the last one is side, no? Okay. Side. So of course, PT is common. Then QT is equal to TS. Why? Diagonals bisect in the rhombus. And then the last one, PQ is equal to PS. Why? Because all sides equal in their rhombus. Okay. In what case of congruency is this? We use three sides. Side. Okay. Easy. Okay. Look at the next question. Next page, page 24. Thank you. So here we are told that in the diagram, angle P is equal to angle S as it's marked there, and then we are told that QT is equal to TR. Prove that PQ is equal to QS. So what are we going to do here? We're going to prove that one triangle is congruent to the other. Not so. By doing that, we know that all the corresponding angles and all the corresponding sides are equal. Okay. So to prove congruency, it's going to be 4 cases of congruency, which is side, 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 angle, side, angle, angle, side, and RHS. Okay. So where do we start? We name the triangles we're working with. In triangle, PQT, and triangle. So P corresponds S, Q looks like corresponding with R, and T of course. What can we say about those two triangles? Angle PS is equal to angle SY. Given. Next, QT is equal to RT. Why? Given. So now I just need one side, one angle. Sorry? T1 is equal to T2. And the reasoning? Vertically opposite. Is that enough to conclude congruency? Yes. So therefore triangle PQT is congruent to triangle SRT. Why? Angle, angle. So now it's enough for us to conclude that PQ is equal to SR. Therefore PQ is equal to SR. Why? Because triangle PQT is congruent to triangle SRT. Okay. Next, still on the same page?
Yes, sir.
Page before. We are told that in the diagram AD is equal to CD and BD bisect ADC, which means to say D1 is equal to D2. Prove that A2 is equal to C2. So I'm going to prove that. Sorry? What? Did I tell you it's okay? No. So you must first prove it's okay. Are you going to prove it's okay? That is not enough to prove it's okay. Because I remember, I could have two pairs of that size being equal. And then I got this. Is that the kite? Is that the kite? No. It's not enough, it's not sufficient for us to prove it's a kite. For us to prove it's a kite is either two pairs of opposite angle, or two pairs of adjacent sides. That could be a kite. You understand? So that's not going to be, it's not enough to prove it's a kite. You can't say it looks equal. No. Anybody have an idea? Congruency. Yes. Which triangles are we going to work in? In triangle A, B, D, and triangle C, B, D. Right. What can we say? AD is equal to DC. Why? Give it. Next. DB is common, yes, nice. One more. Angle A. Why? No. You know triangle yet? for that to be the case? Angles opposite equal? No. What is the way? Yeah, what about that? BD bisect angle D. So what does that mean? D1 is equal to D2. Why? Because it's given that BD bisect EDC or EDF, whatever. Is that now not enough to conclude congruency? Side, angle, side. So we say therefore triangle ABD is congruent to triangle CBD. Why? Because of side angles. So that means to say all the corresponding sides and all the corresponding angles are equal. So angle A is equal to angle D. Can you see in those two triangles, angle A is indeed equal to angle C, sorry. I read this as a D triangle. No? Angle A is equal to angle D, angle B is equal to angle B, and angle D is equal to angle D. Can you see that, people? Also, AB, the length of AB is equal to the length of BC, and the length of BD is the length of BD, which is a common side. You understand? So now I can conclude, therefore, angle A2 is equal to angle C2. Why? Because triangle ABD is congruent to triangle CBD. Okay. So I'm going to put a marking in here to note that is proven already equal. Okay. Then in number 2, they asked us to prove that A1 is equal to C1. Now you're going to do that. What is A1? A1 is equal to 180 minus A2. Why? Angles in a straight line. Okay. A1 is equal to 180 minus A2. Or A1 plus A2 is 180, straight line, and then that's straight line. People, what is C1 equal to? 180 minus C2. Why? Straight line. Or again, you could have first said C1 plus C2 is 180, straight line. And then C1 is equal to 180 minus C2. Let's say, hang on. Yes?
So could you have gone alternate angles with A1 being equal to B1?
Can we go alternate angles? Why not? No better now. No problem. People say, hang on. But is it not that A2 is equal to C2? We just proved that now. So say for argument's sake, A2 was 80. Then that would have been 180 minus 80, which is 100. And this would have been 180 minus 80, which is 100. What if A2 was 20? It would have been 180 minus 20, which is 160. 180 minus, then that would have been the same values. Not so. So what do we say? So we say since A2 is equal to C2. Where do we get this from? It's given. Proven above, yes. Proven above. Which is proven in 1. Therefore, angle A1 is equal to angle C1. Beautiful. Keep on lying to yourself. Tell yourselves this is, you like this. You like the challenge. You lie to yourself until you start believing it. Okay. Start believing the lies you tell yourself. Wanna move on? Next page. Okay, so we'll go into the next video. Okay.